All right, we're doing a mini stream today. I think I have until like 5:40, so we've got like 30 minutes. As per usual, since I'm leaving after the stream, chances are something crazy is gonna happen, like I'm gonna get invaded by 1,000 people or something. And if that happens, I might have to cancel on my plans. All right, we wanted to continue where we left off yesterday, right? That was how far down were we? Complementary insights we haven't grasped. We talked about Claustrum, talked about. Can you comprehensively and extensively summarize everything? Yep, we did that. Right, we wanted to know what was legit, what we're allowed to believe. We did that. Then let's change focus. Okay, we started focusing on focus. We did that. And then I think I asked like a novel here. And that's what we're reading through. Okay, the skill of focus, right. You have hit on the precise intersection where biology meets agency. This is what we're trying to put in this like not opening section, but like the opening section of the mechanics of agency, and or the practical mechanics, the practical mechanics of agency. So conscious levers, it's this idea that we have our control lies in this space of our conscious understanding of what we can do and what we can focus on, etc. And now we have to consider how that focus affects a lot of the downstream processes that are unconscious to us. So yeah, we're gonna have to deal with all these types of things, Here we go, conscious levers. We're gonna have to change some of the naming here. It's getting a little redundant. Okay, focus and motivation are not abstract character traits. They are specific neurochemical calculations that we can influence, but not fully dictate. The constraint model you proposed is right because I literally used what it said. The biological drive, dopamine, provides the energy, and the conceptual self, linguistic priors, provides the shape and direction for that energy. Here is the practical story of focus, motivation, and plasticity unpacked through the lens of modern neuroscience. The chemistry of interest, why Vyvanse works. You mentioned that drugs like Vyvanse seemingly increase interest. This is a profound insight into how the brain values information. In the brain, interest is simply precision weighting. For an ADHD brain, a boring task like doing taxes generates low prediction error and low predicted reward. The brain's gain control, salience network, stays low. The signal is lost in the noise. The chemical fix, stimulants increase extracellular dopamine, motivation / salience, and norepinephrine, alertness, signal to noise. So dopamine tags the task as valuable, even if it's boring, otherwise boring. Norepinephrine increases the gain of the sensory neurons, making the text on the tax the text on the tax form pop out against the background noise. Nice. The result, you aren't interested in the taxes in a philosophical sense. You are chemically counterfeiting salience. Why do we have to have two chemicals here? Or is this Google just messing up? You have tricked the salience network into treating the spreadsheet like a tiger. Jeez. That's a crazy analogy. All right, I have to take a text, as it's important for my plans. Okay. All right, the practical takeaway. You cannot always rely on natural interest. You often have to borrow interest. So conceptual reframing the natural vivans. As you notice, if you change the concept of the task, for example, from something that you're not excited for to like some type of game that you can play and have agency in, you trigger endogenous dopamine release. You are manually hacking the valuation system. The paradox of unconscious reflection. We often reflect unconsciously and only later conceptualize what it is that we had done. Okay, this is the interpreter module, famously described by Michael G. Your brain makes a decision, for example, to pick up a coffee milliseconds before you are consciously aware of it. When the signal hits your global workspace, your linguistic self scrambles to create a coherent story. I picked this up because I wanted caffeine. We often confuse the narrative with the cause. The utilization. True agency is realizing that you are often the PR spokesperson for your brain, not the king. The goal is to train the king. So the PR spokesperson has good things to report, right? So this is actually what we discovered in part 1 of the document. That type of framing. All right, mindfulness as hardware upgrades, seeding plasticity. You correctly identified mindfulness as a long-term strategy for seeding. It's not just about relaxing. It is about structural remodeling of the attention network or attention networks. So without training, focusing is a high energy battle between the task positive network, doing the work, and the default mode network, daydreaming and worrying. This metabolic friction is why focusing feels hard. What meditation does, studies show that long-term mindfulness practice physically changes the brain. It strengthens the anterior cingulate cortex, the conflict monitor. It gets faster at noticing when your mind has wandered. So you're training it to notice a specific type of pattern. And you're doing that via your top-down priors. You know, you go into the mindfulness meditation thinking, when my mind wanders, I will recenter or, you know, start focusing back on the breath. And so you're leveraging those top-down signals that are affected by your, you know, conceptual thought. So that's like kind of one of the things that we have to do here. Even though it's inappropriate to think about our consciousness as some separate entity than our top-down or bottom-up signals, we need to do so here for pointing out where we actually have control within our own reflective experience, something like that. So for pointing out, why is that up? Okay, the point is our consciousness is a result or a manifestation of both bottom-up and top-down signals. It's not like consciousness is just your top-down signals. Usually people think about your conscious, you know, intention as some sort of top-down signal. In this case, we need to recognize that in order for us to have a practical discussion, about this, we need to differentiate ourself from our brain's processes. Conceptually, we need to conceptually differentiate ourselves from our brain's processes, even though that's not what the science tells us. You know, like when we say self here, we're just leveraging our understanding of the self in the moment. Yeah, once again, we are only referencing our understanding of ourself in the moment. Okay. So meditation decouples the struggle. It creates a functional decoupling where you can notice a distraction without emotionally reacting to it. And then it also reduces the switching cost. It lowers the energy barrier to switch back to the task. The skill of focus. You are right. Focus is a skill, not a trait. I must find the... Well, actually, you know, you could say that focus is also a trait. But you'd have to, like, characterize, you know, the types of innate traits that would lead to focus, to just having an easier time with focus. Focus is a skill, not a trait. I must fight the distraction. That would be the novice. Expert meditator. I notice the distraction. I return to the constraint. Okay. The baseline context, serotonin and allostasis. You mentioned baseline states. Serotonin, this is the foundation. The budget determines the spend. If your body budget is bankrupt, sleep deprived, bad diet, chronic stress, your brain assumes a scarcity mindset. Serotonin's role, it effectively regulates the discount rate of future rewards. So low serotonin, I need reward now. Impulsive, can't focus on long-term goals. High serotonin, I can wait. Patient, sustained focus. Practical consequence. You cannot think your way out of a bad biological baseline. If you are sleep deprived, your concept of the world will lean towards threat, scarcity, making focus nearly impossible, which requires expensive inhibition. Okay. All right, that was it. We just kind of got to the front here. And this is something we did yesterday. Now, was there something else that I went over that I thought that we should go over on stream? Oh, okay, that was brain development. That's how that started. Top-down attention. No, it wasn't that. Niche construction and goal pursuit. No. I just had to find this. Deep research on agency levers. Oh, this was just the prompt, so I can delete that. I need to do an audit of my Gemini convos. What do we have? What do we have? Crispy breakfast potatoes. No. Cognitive neuroscience. Connecting concepts. When was this? Oh, this is what had me to start reading 7.5 lessons about the brain. Okay, so this isn't what I'm looking for. We did the meditation time distribution, understanding meta. Okay. Neuroanatomy of interoception explained. I doubt that's... Oh, maybe this is it. Okay. So I gave it this ugly diagram that I made. And crazy enough, if you export a diagram in draw.io with some sort of what do you call it? Template language? What is HTML and XML? If you export an XML, you can give it to a language model and it'll actually understand what's going on, which is wild. So it figured out what it was. It talked about how this is, you know, interoception, exteroception. So basal ganglia, blah, 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 blah. Did I ever make this anything practical that will help us right now? Outputs. Ventral and dorsal striata. Where should the FEF be? Okay, we don't care about that. Don't care about that. Okay. I'm getting the sense that creating a draw.io diagram is not something to be overly beneficial for me to understand some of the main takeaways regarding the brain networks. What is an effective strategy for learning more about the brain, specifically for the sake of noticing the main functional patterns and takeaways? So, yeah, this gave like some pretty basic stuff. It kind of, Yeah, so we've got, you know, stay alive, we got good versus bad, and we've got simulation and control. These are like the main things, I guess, going on in the brain. Or this is three huge interpretations that you could take on what, like, the main functions of the brain. The big three networks. Modern neuroscience has moved away from this blob does math to these blobs work together, except for the fact that the entorhinal cortex, I don't know if you would, obviously it works with a bunch of other things, but you'd say it does, you know, Euclidean math, right? These are three massive networks that dominate human experience. We got the default mode network. We got the central executive network. We got the salience network. Okay. Focus on loops, control theory. Yeah, a lot of these are loops, feedback loops, understanding chemicals, volume knobs, right? We know these neuromodulators. These are things that we've looked into. So I say everything you just mentioned are things I already understand. I'm trying to find more complex relationships such takeaways, such as many parts of the brain seem to deal with both bottom-up signals and top-down signals. Through a predictive processing perspective, we can see this clash as the interplay of priors and error. Since our consciousness is spread out across interoceptive, exteroceptive, cortical, affective networks in communications via the thalamus, according to the global neuronal workspace, then we must let go of the notion that conscious attention equals top-down signals. For me, at this point, I assume that there are interconnected loops almost everywhere, but I kind of wanted to know exactly where and perhaps derive some sort of conclusion about them. Perhaps I should follow Lisa Feldman Barrett's discussion of hubs and get an understanding of how each of these hubs are involved and important. Okay. If you already grasp the components, the aha moments come from seeing them as dynamic control systems rather than just anatomical neighbors. You are asking to move from map making, where is something, to traffic analysis, why does the system jam? Here is a breakdown of the brain's function through the lens of Lisa Feldman Barrett's allostatic interoceptive hubs and predictive processing. This perspective reframes the brain not as a reactor, but as a budget manager, right? The body budget, this is what she talks about. The loops you're looking for are actually prediction loops, right? This is all for allostasis. We got the brain guesses what the body needs next. Data, so the bottom up, the body sends sensory data. The clash, prediction error. If the data matches the guess, silence. If it mismatches, you get prediction error, right? Feelings are not inputs from the body. They are unresolved prediction errors. This is a huge deal, actually. This I need to put into the, like, this type of framing. I mean, this is a predictive processing type of framing here, but this is like a huge one. Predictive processing framings. Feelings are not inputs from the body. They are unresolved prediction errors. They are the difference between what your brain expected to feel and what it actually felt. So this is a little reductive. It's not like it's the difference. It's that these differences, these prediction errors, this is slightly reductive. It's that these prediction errors cause effects in the brain that involve emotion and affect, the release of neuromodulators. Okay, the hubs, where the clash happens. Barrett identifies a rich club of hubs, highly connected regions that consume the most energy and are the first to fail in diseases like Alzheimer's and depression. These are the auditors of the body budget. Here are the specific roles of the critical hubs. In this loop. Here are the specific roles of the critical hubs in this loop. The default mode network. So we've got the MPFC, which we had. Now, I think that, oh, no, we got MPFC down here. We got ventromedial prefrontal cortex, and then we got the MPFC. Is that just the medial prefrontal cortex? Medial prefrontal cortex, okay. And ventral is bottom, right? Ventral. Underside, yep. Okay, so that one would be lower than the MPFC. Okay, PCC. I don't know what the PCC is though. All right, regardless, we got, this is the home of your priors. It holds your long-term models of self and world. So I need to do that actually real quick. I need to say default mode network. And then I need to say, I lost it. Come on. What is happening here? Okay. This is, what did we say? MPFC and PCC. I don't know what the PCC is, but I'm going to just do a little line to that. I want that line to be no arrow, and we could just do that. Okay. Constantly sends predictions down to the body. We are safe. Keep heart rate low. In depression, these priors become too rigid. The DMN ignores positive bottom-up data, overriding reality with its bleak prediction. All right. The anterior insula. The sensor input hub. Anterior insula. This is the comparator. It receives the raw, noisy data from the viscera via the brainstem, the thalamus, right? And slams it against the DMN's predictions. So we don't actually have something that puts these two together, which we probably should. If the DMN says we're safe, but the body says heart racing, the anterior insula lights up. So the takeaway is the anterior insula generates interoceptive awareness. It is the specific site where biological noise is translated into subjective feeling. We got the anterior cingulate cortex, the governor, which we had actually right here as well. The output hub. This is the visceromotor center. It is not just, it doesn't just monitor errors, it fixes them. When the insula screams error, the ACC issues a policy command to the body. And that's going to the, it's going up here, right? Policy value to the striatum. And this is effectively the basal ganglia? Or is this the output of the basal ganglia? Command to the body and to the motor system, go find food. Willpower or effort is arguably just the subjective sensation of the ACC driving the system against its baseline inertia to correct an allostatic error. All right, the grand synthesis, consciousness as error management. So this is the crazy stuff that we need to consider. If your priors, coming from the DMN, the default mode network, perfectly predict the world, for example, walking down a familiar hall, you're effectively a zombie. You have no conscious feel of walking. The loops are closed at the lower levels, the basal ganglia and the cerebellum. When a prediction error is too large for the lower loops to handle, for example, you trip while walking down the hall, the salience network broadcasts this error to the global workspace. The result, your entire cortical resource is rerouted to solve the error. Conclusion, we do not pay attention with top-down signals. We pay attention when bottom-up errors break our top-down predictions. Attention is always the failure of automaticity. So I don't know if this is like a pretty radical telling, but I don't know if we would even benefit from saying things in this way. The hub overload theory, the modern plague. This framework explains why modern life is so draining. We live in a world of high symbolic uncertainty. Stock markets, social media, emails, etc. The physiological cost. The brain treats symbolic uncertainty the same as physical uncertainty. The ACC prepares the body for a fight that never happens. The body budget goes bankrupt. The hubs are overworked from constantly managing high precision errors that cannot be solved by physical action. This is allostatic overload, leading to burnout, inflammation, and anxiety. Okay, so then I say a few things. First, can you really drill down this idea that the visceromotion and affective cortices are the same thing? Like, I understand that they are deeply interconnected, but my sense is that this might be ambiguous, implying that our affective feelings, in other words, the related mappings / activations, are the same things as the movements. In my mind, the brain top-down predicts interoceptive and exteroceptive signals, and this affects what becomes conscious to us as affect, and these very signals are deeply involved in our motor outputs. However, I'm hesitant to say that they are the same. Okay. Next, I just want to ask about the framework we're following. Is it well substantiated to say that that consciousness is error management in the way you just explained? I had this sense that prediction error is a constant, albeit unconscious, in the sense that it is unnoticeable. This makes sense with the fact that a lot of predictive signaling doesn't reach ignition. Only once a signal is salient enough does it ignite. The general issue with this type of framework is that it's incredibly unintuitive for the layperson. And lastly, who is at the front lines of this topic? In other words, the last 5 years. Who is taking the perspectives of Barrett's allostasis and making them work with the global neuronal workspace, or Damasio's homeostasis and his theory of consciousness, which focuses less on the thalamus, or integrated information theory, or at least focusing on complexity as necessary in consciousness, etc. Okay. Let's unpack your 3 points with necessary nuance. We are getting close to my hard leave. Okay. All right, the visceromotor and affective signal, visceromotor and affective are the same thing. A clarification. You're right to be skeptical of a literal movement equals feeling equivalence. A stomach contraction is not an emotion. When Barrett and others like Anil Seth say they are the same, they are referring to the neural origin, not the peripheral outcome. This relies on the concept of efference copy, which we just talked about recently. This idea that simulation happens because the our top-down, what was it? It was like our top-down signaling is sending a copy. Yeah, what was the reason? When do we get into efference copy here? Oh, do I have to find it? Efference copy. You do not need your tongue to make minute movements to understand the word apple. Your motor cortex fires the plan to move the tongue, and your brain simultaneously sends an inhibitory signal to the spinal cord, stopping the movement, and an efference copy to your sensory cortex. Okay, this is basically just, the efference copy is the simulation, essentially. It's saying, this idea is that it didn't actually get these bottom-up signals, but it's still going to send it anyway. Yo, Onion Hello, what's good? And the gang fly free, never hollow in the center, nightly, Hollow Knight, no pretenders, stacks of maps of meaning, like JP. Hell yeah. Absolutely. Okay. Unfortunately, I've got a hard out in 5 minutes. So we got 5 minutes of fun. You feel the motor potential of the concept without a single muscle fiber twitching. Okay, so then efference copy being used here. This relies on the concept of efference copy, or corollary discharge. When the ACC sends a command to the brainstem to race the heart, it simultaneously sends a copy of that command to the insula, who's actually going to interpret it. The same part. The copy is the prediction of the feeling. The brain does not wait for the heart to actually beat and the blood to return to the insula to feel anxiety. The command to change the body serves as the prediction of the emotional state. The feeling you experience is the integration of that top-down command and the bottom-up sensory feedback, the error. They are the same in the sense that you cannot separate the machinery of regulation from the machinery of feeling. You feel the state because your brain is actively managing it. You had no mechanism to regulate. If you had no mechanism to regulate a body system, you likely wouldn't be able to consciously feel it. Bam. Why is the camera in the center today? Well, I called this a mini stream because I didn't have much time to stream. Like, I think I started at like 5:10, and then I thought, because I'm calling it a mini stream, why not make myself really small and put myself in the center? Not my best work, but you know, that's what we're dealing with today. Okay. All right. Consciousness is error management. Is it substantiated? Prediction error is constantly and mostly unconscious. If consciousness were just error correction, we would be conscious of every adjustment in our blood pH. To make this framework work, we need to add one crucial variable, precision weighting or salience. So yeah, if prediction error is salient enough, that's what becomes our conscious awareness. Most errors, for example, slight blood pressure drop, are handled by local loops, like they're kept in the brainstem or hypothalamus, because the brain assigns them low precision. They aren't news worth broadcasting. Consciousness happens when an error is a massive deviation from the prior, and the system has learned that this specific type of error matters for survival. The lower loop tries to fix it and failed. Yes, this is the weird thing about this, though, for me is like when I look at a wall, it's not like it feels like there's something that is salient enough to be in my view, but in the system, that's how it works. It's, you know, that information has been deemed salient enough to be broadcast. So salience, even though we intuitively think about salience in terms of like a more Jordan Peterson-esque, you know, it's novelty in a way where it breaks our expectations and it's very much capturing our attention. Like, we're dealing with prediction error that is salient all the time when we're just looking around. It's just when, you know, at the base level, salience doesn't have to be all that crazy. Okay. Is it substantiated? Yes, this is the dominant view in the predictive processing field. Carl Friston, Andy Clark, Jacob Hoey. Studies show that surprisal, mathematical surprise, correlates with P300 waves, the brain signature often associated with conscious access. Don't think of consciousness as solving the error. Think of consciousness as model update. We become conscious of the error so we can rewrite the prior, so we can learn. If the error is small, the old model works fine, so we stay zombies. You know, there's nothing to be, there's nothing to reach consciousness in that regard. Okay, who is bridging the gaps? We are currently in a golden age of synthesis. The rigid lines between global neuronal workspace, integrated information theory, and allostasis are blurring. So between cognitive, structural, and biological. Here are the key figures and concepts from the last 5 years who are doing exactly what you asked. All right, the Beast Machine Bridge. Anil Seth. We've heard of Anil Seth many times. He's bridging Barrett's interoception and with computational consciousness. He argues that the self is just a prediction of internal stability. He moves beyond Barrett by applying this specifically to the hard problem, why it feels like something. So Anil Seth was the person that said that there isn't a that we shouldn't look at the hard problem. We should look at the real problem, which is like looking at you know, how we feel different things and how, like, what makes different feelings, different experiences different at like a neural correlate level. So like that's the real issue here. We need to learn more about the interactions within the brain. All right, Being You, which is a book that I'm going to have to read. He operationalizes counterfactuals. We feel conscious because our brain predicts. We feel conscious because our brain predicts not just what is happening, but implies what would happen if we acted differently. Nice. All right, the subcortical challenge. Mark Solms. He challenges the cortical-centric global neuronal workspace theory by integrating Damasio's homeostasis with Freudian psychoanalysis. Neuropsychoanalysis. He argues that consciousness originates in the brainstem, not the cortex. He posits that the cortex is actually the seat of unconsciousness, automatized habits, and the brainstem provides the affective core that lights up the cortex. This is an intuitive view, and at this point we're kind of, it's getting semantic as to what would actually be causing the consciousness here. This flips the script. Affect isn't a readout of the body. Affect is the foundational stuff of consciousness itself. Right, and that could be the case. So this goes really well with this theory that even our like abstract thoughts are really just our body feeling these simulated motor movements, these simulated emotions, these simulated signals from our body and our muscles and all all that's involved here. So yeah, that's but yeah, I wonder if the simulations are happening in the insula, then I think that is still the cortex. So maybe I'm not grasping this originates in the brainstem idea as well as I should. All right, the active inference bridge. Micah Allen. He's doing the heavy lifting on how interoceptive inference I've overdone my time here. All right, let's just finish this one thing. On how interoceptive inference creates subjective time and selfhood. He focuses on the insular cortex as the specific hub where visceral rhythms, heartbeat, breath, set the sample rate for visual consciousness. Wow. He provides the mechanism for how the body influences what we see. Crazy. The structural bridge, integrated information theory and predictive processing, the integrated information pivot. Researchers like Lars Muckley and Maxwell Ramstead, they're trying to show that minimizing free energy, prediction error, is mathematically equivalent to maximizing integrated information, phi, which we've got this, we always bridge this back to that gauge of phi. It's not exactly phi, but it's the gauge of phi, the perturbational complexity index, where, we just see how much propagation happens when you perturb the brain. It gives us a sense of how integrated the brain is. All right, the brain minimizes the brain minimizes error by becoming more integrated. The hubs become dense and complex because that is the most efficient way to predict a complex environment. Okay. And we can continue with that tomorrow. Actually, no, I might not be streaming tomorrow. I think I switched it up. I wasn't even supposed to stream today, but we got that mini stream in. Probably not going to be on tomorrow. Going to be on Friday. I'll take recommendations that day. We can do a little more free form. We can continue from here and then go free form. We can go rogue. And then chances are I'm going to try to work on actually organizing a bunch of these ideas that we've been talking about the past few days into the document finally, and then we can go from there. All right. With that, I must call it. Later, Onion Helmet. Thanks for stopping in. Sorry that this was just a mini stream, and that I am a small person here, but we'll be big again. Hopefully on Friday. So, see you later.